Well, I won't admit that we've had any conversations like that, but I can guarantee those conversations are occurring within the utilities. Because you're not just gonna, there's compliance, which is one thing, and there's security, which is something different, right? They're two fundamentally different things. One, I'm just trying to get past the auditor so that, all I want to do is get out of that. The other, from the security side, they are thinking about that. I mean, the whole purpose of, I look at system protection, for example. The whole purpose of system protection is to protect the system. They're technically doing security. They don't look at it that way. They think they're just doing their job, or they're just switching relays or whatever. But really, they're the security for the grid. They've got the same sort of people like that, within distribution control systems. Every control system, every control center I've ever been to has had some kind of cybersecurity resource, some kind of physical security. It's there, the discussions are happening, but there's just no formal, approach for that. I think that's kind of the issue. There's been people talking about, yeah, we should, apply 853 to, to everything, basically. Is that the right approach? I don't know if that'll work. I've tried that. I've worked at PMAs, like I said before, and we looked at, the main complaint was that, we just didn't have the resources to do, to really do both effectively.
I guess the question was really, in order to determine what assets are critical, this is about rules coming out. Has there been work done to determine that everything that follows the load rules, everything that says, you're really not critical, has there been work done to simulate the effect of failures on the grid? When you look at the 2002 blackout, it was a cascading event. There's been improvements made since then, but the original event, I think, was less than some of these thresholds. And so, is there work being done to determine that these are the right thresholds? And
Check.
I think the smaller is really irrelevant.
And there's certainly been research done to show that there's been, disruptions at a smaller level that can cascade and cause problems. Not all of them are a result of losing generation. I think there was something on the West Coast that were showing something. There was a Chinese paper that was done about a year or two ago that sort of concluded, again, these were more cascading effects rather than lost generation. You really also talking about where you are in the I mean, you're in the middle. Mike and I were in the middle of the plains doing work at a power plant there. They had a total of two units, total of 660 megawatts. If they went out, WAPA and dams, they would have taken care of the issue. And even if they probably went higher than that, they probably would have. You get in Southern California, parts of Florida, other places in the middle of the summer, suddenly you've got less reserve that you can rely on, and so forth. So, I agree with you. There probably needs to be simulations in all those aspects. But, and Mike can probably talk more about, what the perception is. It's all going to be, where you are and, how, and what the particular time of year it is and all these other factors that go into it, right?
Yeah, it pretty much, just depends. I mean, I don't, I guess, Jim, you could tell us if there's an official study underway to look at this kind of stuff. I mean, there are projects. There's like the WISP project in the West, which is looking at synchrophaser data, but
Way back when the CIP standards team was taking a look at what would be the criteria for high, medium, and low for BES assets, and then the cyber assets that would support those BES assets, we reached out to the NERC Planning Committee and Operations Committee for subject matter experts on the operations side, and the Planning Committee for folks that do transmission and congestion studies and so forth like that from across the various regions. And the focus, and we brought in 4 or 5 folks that are involved in BES reliability from those perspectives. They went back, and a lot of the numbers that you see in the new CIP 2 version 4, the criteria that was put in there for bright line was based upon other standards and work done on assessing the impact of disturbances and so forth like that. And every threshold that you see in there was based upon some type of study or engineering metrics as to try to what would be effective. At one point in time, there were some metrics that applied to the eastern and western interconnections, and other metrics that applied to Quebec and ERCOT because we're smaller interconnections. There's 4 interconnections in North America. Actually, there's 5. I think New Brunswick counts separately. I can't remember exactly how that works, but there's 4 major interconnections in the U.S. And so some of those metrics and so forth, how much frequency excursions allowed, et cetera. depending on different studies. So it's not just NERC CIPs that were looked at. A lot of the EOPs and BAL standards and so forth like that have metrics in them. And so the numbers you see in the attachment 1 of CIP 2 version 4 for the new CA identification criteria did have an engineering basis. However, we did not go out and do specific studies because we, quote unquote, didn't have time to do a year-long study and get all the metrics in.
Makes sense. We'll move on to the next slide. You know, we're going to just go through, hit these things individually and talk about, you know, what they are and, you know, what they basically mean. So supervisor control and data acquisition, and you can go into the CIP 2 standard and read this. You know, basically does monitoring and controlling. It's got, you know, automatic generation most of the time. There's real-time power system modeling and real-time inter-utility data exchange. And those are basically the requirements that make SCADA critical. One of the things that I want to talk about, one of the things that I've, you know, as I'm going through this stuff and looking at all these things is, what does that really mean from a risk perspective? What is the impact? Because NERC doesn't require you to, you know, tell them what the impact. They just tell you that, you know, it's a critical impact. What I think we need to do is, you know, as we're going through these things and really for our own education so that, you know, we as cybersecurity, but I don't know if anyone there is a power engineer, but I'm a cybersecurity guy. I'm definitely not an engineer. Understand why it is critical and what the impact of this going down is, or what could a threat source do if they actually got into the system? What kind of impact could they create? And, you know, I think that kind of goes back to what you were saying, Andrew, not necessarily the comment you made, but, you know, an impact analysis, an internal impact analysis. I think that's what we really need here so that we can understand the true, you know, the true risk associated with this. And, you know, any thoughts on, you know, what you think the impact of something like this might be? If it were compromised or if it were taken down? Well, you know, obviously I think the impact is high because, you know, this is probably the most critical asset, you know, of all your critical critical assets because it, you know, it does all, you know, these functions and, you know, has tentacles pretty much into everything. So.
Would you assess the
Yeah.
impact there?
Oh. Yeah, well, you don't necessarily do an assessment. It basically just says that, you know, the control center and backup control centers are critical. There's really no, and I could be wrong, but there's really no criteria. I mean, if you have one and you're registered, it's critical. And then you've got to assess all the cyber assets in it to determine whether or not there are any critical cyber assets.
Go back and read the guidelines, and those guidelines are not the law, but it's not just guidelines for assessing assets, critical
Mm-hmm.
critical assets and critical cyber assets. And when you're doing the assessment for a critical asset, you go through some of the same steps, you know, that you do when you're assessing whether an asset is a critical cyber asset.
Sure.
You take those same steps. So within the documents that I've seen, within my organization, we've assessed, or because I'm new in this organization, they've assessed what the impact would be.
Mm-hmm.
If that device was degraded or no longer available or whatever. So that's part of their assessment. Otherwise, how do you know what it's
Well, yeah.
it's going to affect the local electric system?
Yeah, I think the difference is that in that assessment, though, they're just saying, is it critical or is it not? There's no, is it a high critical? Is it, you know, what is the criticality? Because what you're trying to get to is you're trying to get to a point where you can identify what is the risk. And if I just say, you know, the risk is critical, then, I mean, it's critical. You know what I'm saying? There's no, and what ends up happening is that now I'm only doing cybersecurity for what is critical. I'm not looking at the greater system.
Yeah.
You know?
One of the things, if you go back and look at the NERC CIP standards and also look at the CIPC guidelines for critical asset identification, they talk in there about the risk-based assessment methodology, assuming that there's a risk factor of 1 because you can frankly break into just about any SCADA system you want to if you can get access to it. So the risk is high. So instead of really doing a risk assessment, you're doing more of an impact analysis. What is the impact of losing that system? And I think you all addressed that well. But there's the other aspect of it that a lot of folks in the utility industry don't think about, and that is what is the impact of an outsider or an adversary gaining control of that SCADA system and either masking what's going on or causing indications to the operator which will cause them to take other actions which could cause equipment damage. So there's more to it than just having an outage. It's, if an adversary's got control of that system and can inject incorrect status to the operators, then other problems can occur. So it's much more complicated than just losing the asset. And that's something that a lot of power system engineering folks don't even think about is, you know, why would anybody do that? Well, because they're bad people. And if you talk to the DHS and the Department of Energy folks and their Intel Ops analysis, and you go over to some of those three-letter agencies which we're not allowed to talk about in public, et cetera, they will tell you we live in contested space where there are adversaries out there with the skills, capability, desires, motives, et cetera, to jump in there and do things to our systems. We've seen it in foreign nations where adversaries have taken over the control systems and held them hostage until such time as they get payments. So the risk is there, and it's an impact analysis. If somebody takes hold of that asset, what can they do to you?
And that's sort of, that's a good comment. That's sort of what, I guess what I'm trying to say is that, you know, the CIP 2 methodology doesn't take into account integrity. It just looks at really availability. They're looking at if something, you know, what is the reliability of the system? You know, if it goes down, what's going to happen, basically. They're not really talking about the impact, you know, of the
Well, if you look at the new CIP 2 version 4, you will find in there it talks about misuse of systems as one of the criteria down in the fine
but
print.
they're still concerned with the internal users, right? They're internal concerned with, you know, what is a dispatch?
Should be both.
Yeah. But does it say that in there, or is it, are they talking about
It talks about intentional misuse in attachment 1
Okay.
of the new CIP standards.
Yeah, and that's certainly a broad category of things. One of the things that you're going to find with smart grid that's even more interesting is the amount of data that you're getting from all over that could all influence. As Jim was alluding to, it's not simply about getting your hands on the controls and, you know, flipping a switch or doing something else. All you need is to send somebody bad data that they rely on to take an action. So, you know, you can, tell somebody they just, won the lottery and they'll drive down the street or whatever. You don't actually have to force them to do anything. You know what the action is going to be based on what the information that you get them is. So all you need to do, particularly when we start talking about smart grid, is to be able to say, you know, here's data from all these meters saying this, the voltage level on the meter. That's going to cause you to adjust potentially generation based on that data. So even though you may say these meters, they're just measuring data, they may not even have any control functions depending upon how you implement them, the fact that you're using it to measure information is going to have an influence on the actions people take, because that's exactly why those things are there. They're there to help you make better decisions. And if the wrong information comes out, it can cause you to make bad decisions.
And that's a good point when you're talking about the smart grid, because as we continue to deploy intelligence further and further out from the control center, because I'm a cybersecurity guy too, so that's the hat that I wear. It becomes a lot easier to breach a system because now you have access points on utility poles. You know, could be out in the middle of nowhere. Someone can sit out there, you know, and he can hack all that. So you have to put in the proper protections, and that's what I'm debating with, because I work with a company of guys that's been in this industry for a long time. And when you talk security to these guys, and they merely think about, they still have that old mindset that if the power goes out, we roll the truck. You know what I mean? That's what we do. We roll the truck, the power goes out. They don't necessarily think about, you know, a breach in the system where someone can hack into the system and get back to the control center and create a mischief for you. And that's the problem that we're really having. And I don't, in my company, I don't see that getting elevated to the level of importance that's required until we have a major breach. And then
And so that's one of the things that, you know, we've been talking about recently is security, is the cybersecurity function within the company at the right level? Because I think we're not getting that visibility because we're not talking to the executives. And that's one of my big things is I think that you need to make sure, we're going back to that leadership requirement, CIP 3R2, you need to make sure that, you know, I don't know if we want to say that should be a cybersecurity person with like kind of the way FISMA does it, but we need the cybersecurity to kind of be up there at that level, and they need to be talking at that level so that.
Mike?
Yeah.
As a regional security coordinator for the ERCOT region, what can I do to help you out at the utility level, to help you get that visibility at the executive level in your organization.
I think, I had this conversation last week with another guy, and I think what we need to do is we need to look at rewriting that CIP 3RT standard and going to a full-blown, this is what a cybersecurity program looks like for a critical infrastructure protection, type system. So, I think in there, I guess what I'm getting to is what ends up happening is that they personally put in that, they always delegate it, right? Because I think the CEO is like the person that's supposed to be responsible, and he always delegates system operations or somebody like that, and then that person has no cybersecurity background, and they're thinking just like the way that you're saying, so basically none of that stuff can ever happen. And by the time they hire a cybersecurity guy, he's 2 or 3 levels below that. He never talked to that guy. And he's, you know how it is when you're in a company and you can't really.
I've seen it suggested that the person at each utility who is the senior manager responsible will have to have had a security certificate or training and certification project on CIP standards to such a point that when they sign off that they are approving it at the executive level, and that sign-off should be at a very high executive level, because if it's down in the weeds, then there's plausible deniability for all the executives. Well, we didn't know what was going on down there, and the intention of having that senior manager, that should be like a CEO, chief system operator, chief compliance officer. That's where we've got it. Our chief compliance officer is our senior manager. He works for the CEO, and he's required on a monthly basis to brief our board of directors and the Public Utility Commission on the efficacy of our cybersecurity compliance and security programs.
That's, if we can.
That's what you have to do is get it to the board.
It's got to get, it's got to go to that level, and a lot of times it, unfortunately, I'm not saying that, again, I'm not saying that SRP is like that, because I'm not talking about, what they do. But, definitely that's something that needs to happen.
So you, what slide are you guys on now?
Oh, well, I guess we better run through, let me run through these.
Well, I'm gonna say, if you want to,
We've got 10 minutes, right?
yeah, this is time for I don't know what your first break is in 10 minutes, right? Yeah.
We got 10 minutes.
Yeah, so.
So yeah, let me get back to this, and let's get through this. So we're talking about, we talked about transmission substations. We talked about why they're critical. I was going to ask you, what do you think the impact is of losing a transmission substation? If some hacker threat breaks into a relay and trips a breaker, what is the impact of that intentionally being done? What is the impact of it going out? That's one of the other criteria. Did you want to add anything to that? I'm sorry.
Right, this is, again, automatic load shedding. We talked about the special protection schemes, and other generation aspects of things as well. They'll cause a shed load. In this respect, this is the smart grid slide. For all practical purposes, we've already discussed the fact that it's still unclear. There's a lot of belief, as Jim and others have said, that this could come into play in the future, and it's certainly something that people should watch for. And all we're saying is understand where you're going to go. I've given presentations before on smart grid about when you deploy AMI, what's your plan for grid automation? What's your plan for transmission automation? You don't have to have the vendors selected. You don't have to have anything else. But figure out how you're going to tie these things together, how your meters are going to send information back that's going to affect generation, that's going to affect demand response and load shed, and think about how these things are getting deployed, because at some point, depending upon how you organize it, you may have to deal with NERC CIP now, or you may have to deal with NERC CIP in the future, as well as other security issues. It's not just about compliance. It's about doing the right thing and being able to keep things secure. And if you're deploying meters with the idea that, we're just doing billing, we're just doing this, and then you find out you're doing volt VAR, you're doing other applications with that could cause a load shedding event, or you're doing demand response, which a lot of utilities need to do to justify the cost of AMI, you're going to put yourself in a position where you could be doing this load shed event. And obviously we can talk a lot more about how you would secure that environment. Customer information systems have not traditionally been part of operations. They've been part of the enterprise side. So there's a lot of different paradigm shifts that may have to occur with that as well.
So I'm going to, we've already kind of talked about this stuff, so I'm going to get kind of like one of the things I want to make sure we talk about is the critical cyber assets and how that methodology is used to develop that list. So I don't know if you guys have any questions about special protection schemes, black start, or, well, actually this is an important one, distribution control systems, which we haven't really talked about. And that's basically, we took this from, I think we did a Google search on DCS, and Got this, basically, these are process control systems. This chart is meant to show you that every little, from dumping coal onto the conveyor belt dumping coal into the, I don't even know what they call that thing, but, each one of these is a process, and there's usually some sort of system in place to actually control that process. Pulverizer, yeah, that's what they call it. Yeah, because we actually, well, seen it multiple times now. But the main thing, and then there's other assets, obviously. The main thing we wanted to get into, though, or to make sure that we covered, is how you identify a critical cyber asset. And, basically, what my recommendation is that, once an asset is declared critical, you need to go and figure out what are all the cyber assets in that facility. Almost like an inventory, basically. And a lot of utilities have Maximo and some other tools they use to basically do that. Once you pull that list, though, let's say we're talking about a special protection scheme, that's a good example. You need to figure out, and I know this kind of goes later in the process, but it makes more sense to do it first. What are the cyber assets in that facility associated with that RAS scheme or special protection scheme that are essential to the special protection scheme, because that's what you're trying to protect, right? And that's usually going to be a subset of everything in the control house. So, once you figure that out and you can mark that box, it doesn't necessarily mean that it's a critical cyber asset. It just means that you have to have it to support that function. The other three steps they have in the process is that you got to figure out if it basically does any sort of routing or if it's dial-up accessible, and it uses basically TCP/IP protocol. It can use other protocols too, but over the IP layer. If it does, then it ends up being a critical cyber asset. If it doesn't, if it's serial connected, the current NERC CIP methodology is that it's not critical, right? So what you end up having in this situation, Josh and I were talking this morning about this, is you've got a lot of times these relays are serial connected to what we call communication processors, which have IP interfaces to them. And what they do is they come over the IP layer into this communication processor, and then they can access these remote serial relays, or IEDs, intelligent electronic devices is the other name for them. The IEDs are not critical because they're serially connected to the communication processor, but the communication processor is critical. The issue is that those systems don't really have any way to, there's really no way to secure it or control access to it or really do anything, because the only thing they understand, there's basically a terminal server. So I know I've got to allow you to access me so that I can, let you have access to these other devices I'm connected to. So that's one of the challenges that you would face, when you start getting into the security discussion associated with critical cyber assets. But this is basically, is it a good process? It seems to be pretty well. It's a good way to, basically get your inventory right, and then a good way to somewhat categorize and catalog what you have. But, it's up for you to decide. But this is basically, I'm taking this right out of CIP 2 R3. And then, of course, the last step is, senior manager has to approve the list of critical cyber assets associated with that.
If I'm not mistaken, I believe in the case of the Iranian nuclear reactor, the connection between the controlling software and the PLC, I believe it was a serial connection. I'm not sure if that was a 420 milliamp, but it was probably not an IP connection. And yet, you saw the kind of damage that it could do to the centrifuges. So we'll have to, obviously, that's being looked at, and there's been lots of controversy about that over the years. But there's certainly issues that understanding that attacking an IP addressed device has cascading impacts to serial connected devices too. And the idea of excluding those, even if they're critical, is a little odd. But obviously, that's something that still being looked at.
And I don't know if you guys, oh, go ahead.
Besides the identification of the CCA or non-CCA, like you mentioned there, what else from a NERC CIP perspective is required as far as documentation or as far as maintaining information?
Well, you end up starting off with, obviously, you're reviewing the process and you're developing a process to meet the policy requirements that NERC CIP's got. The only the documentation you need to have, or the output of that documentation, is usually a list of critical assets, and then the list of critical cyber assets. As I've been told by auditors, you don't necessarily have to document your critical cyber asset methodology, but it's a good practice to do that, right? Because you want the process to be repeatable. I mean, I've even gone as far in the past to document the procedure for actually populating the spreadsheet or this database or whatever, So all that stuff is usually good evidence, good evidence to support the fact that you're in compliance, or that you've done your due diligence. Basically, one of the big debates is, do I really have to touch every asset in my facility? And I would say that you do, simply because, and it's tedious because in control centers there could be like 400 or 500 assets, right? Cyber assets. But I think you need to look at each one, because you need to know, if it's not critical, then why is it not critical? If it is critical, why is it critical? And then basically keep a list of all that, everything. That's all evidence, basically, and that should help you, in an audit.
We're trying to establish a baseline for our Table 3 cyber assets and CCAs. So we're trying to figure out what, from the NERC CIP standpoint, and the minimum needed to establish that baseline. So that's kind of something we're looking at.
The baseline of critical cyber assets? Or?
Yeah, all of our CCAs and our known cyber assets that are there.
I'll tell you what I've tried before in the past is I've just done a spreadsheet like this, and have a tab at the bottom for each facility or each critical asset, and then you can sort by facility and critical asset. The other thing I'm looking at now is a SharePoint list, and you can kind of build a form to basically take these, and you can start putting logic in there to sort the data for you automatically. Any report like that will be good for an audit. I mean, you just want to make sure that you've done your due diligence is the important thing. The more due diligence you do, the better off you're going to be.
Specifically to your question, as an ex-auditor, what you need to do to support the critical cyber assets? To support the determination of those critical cyber assets, you want what Mike has laid out here, right? You want a full inventory of the cyber assets at the site, and some sort of documentation that an auditor can walk through and see the logical determination that this is or is not a critical cyber asset, and then that final produced list of critical cyber assets. So that speaks to the spreadsheet that Mike's talking about, some sort of format like this, some description of what the device does in the system, how it's connected, is that Modbus, is it TCP/IP, what is it, and then walking through, because those are really the only 4 requirements, right? Is it essential? Is it in a control center speaking routable protocol? Does it communicate outside of an ESP, or is it dial-up? That's the only 4 things that can make something critical right now. So
I think we're out of time, but if you have another question, anyone?
Can you repeat that again? The question?
yeah. So just what you need to determine something being critical. Is that what you're?
Essential.
Yeah. Is it essential to operation of the critical asset? Is it communicating via routable protocol within a control center? Is it communicating via routable protocol outside of an electronic security perimeter? And is it dial-up? Or is it dial-up, excuse me.
And we'll go over electronic security perimeter, those things, I think at 1 o'clock today. So it'll make sense. I think that's it. It's 11:01.